Swayam Prabha. Digital India. Educated India.
Welcome back learners. The video is for the subject of geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of climatology. Today we are going to discuss lecture 5 of module 3. The topic of the lecture is secondary wind circulation and regional winds. The video is being recorded by Dr. Pallavi Upreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayamprabha Channels of MHRD, New Delhi, India. Hello dear learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun. In our previous lectures, we have already covered planetary wind circulation and their significance. In this particular video lecture, we will be covering secondary wind circulation and we will be discussing the regional winds of the world in detail. So let's begin. The main objective of this particular video is to understand the secondary wind circulation. What are the main characteristics of secondary wind circulation? How secondary wind circulation is different from planetary wind and tertiary wind circulation. Then we will be discussing what are the different types of secondary wind circulation which exist in different regions of the world. So prominently we'll be discussing the monsoon winds, mountain and valley breeze systems, anabatic and katabatic wind systems, and land and sea breeze. So this is all what we are going to cover as part of secondary wind circulation. Starting with the classification of winds. So when we were discussing the planetary wind system, we have already discussed that winds are broadly classified into three categories. First category is the primary winds or planetary winds, which we have already discussed. Second one is the secondary wind system, which are also called as periodic winds or regional winds. And third category is the tertiary winds or local winds, and all these winds are classified on the basis of their periodicity of occurrence and their location of occurrence. So based on what is the extent of their coverage, based on what is the periodicity of their occurrence, they are divided into three broad categories, and within these three categories we have already discussed the primary winds or planetary wind system, and in this particular video we'll be focusing on secondary wind circulation around the world. What are secondary winds? Secondary winds are basically periodic winds or regional winds. They occur in many locations throughout the world and they are greatly influenced by the regional geographical and geophysical conditions of a particular area. They periodically change their direction in different seasons or different time period of the day. So during the daytime they may have a different direction, and during the night time also they may change their direction, and also the direction of the winds may change according to season. They can also be called as seasonal winds or periodic or variable winds, because their direction is not static, is not same throughout the year. They are also called as variable winds, and they blow for a specific time period exhibiting specific characteristics. They are called as periodic winds, and they seasonally also dominate different regions of the world. Therefore they are also called as seasonal winds. So in the category of seasonal winds, we usually take monsoon winds because they seasonally change their direction. The wind have different direction during the winter time period, whereas there is change in the direction of winds during the summer season. So they are called as seasonal winds. Besides seasonal winds, they may also exhibit characteristics of periodic winds because they are winds which keep flowing periodically pertaining to different time periods of the day. So during the daytime, you may have entirely different set of winds which are blowing as compared to the nighttime. Secondary winds specifically are periodic winds. They are regional in character because they cover a comparatively smaller area when we compare them to planetary winds. Their aerial coverage is comparatively less than planetary winds. So these are secondary winds. So you can say that seasonal winds are movements of air repetitively and predictably driven by changes in large-scale weather patterns. And these seasonal winds occur in many locations throughout the world depending upon the geophysical conditions, depending upon the geographical conditions of a particular area. And the name which is assigned to a particular seasonal wind and the underlying physical force that derive these winds typically depends upon the unique geographical condition which exist in a particular area. So you may have different locations in the same latitude, and in the same latitude you may observe different set of seasonal winds which blow during different time periods in a year and even in different time periods during the daytime also. So these are secondary winds. Now let's look at what are the most important secondary winds which are found around the world. One of the most commonly recognized seasonal wind systems are the monsoon winds, which occur primarily in various regions of South Asia and Southeast Asia. Monsoons were traditionally explained as land and sea breeze systems which exist on comparatively large scale. And they were also sometimes erroneously identified as rainstorm winds or rain-bearing winds. However, today they are considered more or less as seasonal wind systems with distinctive regional characteristics, and the regional characteristics are highly influenced by the existing geographical and geophysical conditions of Southeast and South Asia. So by definition, a monsoon is a wind in the low latitude climates that seasonally change their direction between winter and summer season, characterized by complete 180-degree reversal in the direction of winds from one season to another. So you can see complete reversal of wind system in different seasons of the year, and they are primarily experienced in certain parts of Asia and Southeast Asia, and it is prominently well developed around the Indian subcontinent and Indian Ocean, Bay of Bengal region and Arabian Sea region. So monsoons today are recognized as seasonal wind systems which change their direction with different seasons. So as we have discussed earlier many times that the sun heats up different regions of the earth differently. So when you have summers in the northern hemisphere, you have winters in the southern hemisphere and vice versa. So when you have summers in the northern hemisphere, the monsoon winds act in a completely different manner characterized by entirely different set of characteristics. Whereas with the approach of summer season, the monsoon winds also change their characteristics, change their direction. So we'll be discussing monsoon in detail in the coming videos, but here you have to understand that they are recognized today as seasonal winds. So let's see what happens during the winter season and how they change their direction during the summer season. So during the winter season, what happens that the sun is overhead the Tropic of Capricorn, due to which you have winters in the northern hemisphere and summers in the southern hemisphere. So the land mass of the northern hemisphere loses heat due to prevailing low temperature conditions during the winter solstice, because of which in the northern hemisphere you have high pressure conditions, whereas in the southern hemisphere you have low pressure conditions. So a high pressure region is created to the north of the Indian subcontinent due to prevailing low temperature. So this is the Indian subcontinent. Due to extremely low temperatures, a very high pressure conditions exist in this region of the world. Contrary to this, the southern hemisphere experience summer season. So if you have summers in the southern hemisphere, definitely the temperature will be high, which will lead to low pressure conditions in the southern hemisphere. So with the apparent southward movement of the sun, when the sun is located over the Tropic of Capricorn, you have summers in the southern hemisphere. So because you have summers in the southern hemisphere, all the pressure belts, we have discussed pressure belts in detail in the earlier videos. Please go and check the shifting of pressure belts to understand this concept better. So due to summers in the southern hemisphere, all the pressure belts shift southward, including the intertropical convergence zone. We have already discussed what is intertropical convergence zone. It is the convergence zone where the trade winds converge in the lower tropical areas. So the ITCZ also shift southward. You can see the position of January ITCZ. It is somewhere located just south of geographical equator. The ITCZ establishes itself southward somewhere around 5 to 10 degrees south of equator due to apparent southward movement of the sun. All the trade winds which were earlier merging in this location, now they are merging in this location. Okay, ITCZ. As the trade winds start merging in this location, the direction of winds which exist above the Indian subcontinent is northeastern, because they are blowing from northeastern regions towards the southwestern region. So during the winter season, the trade winds which exist over the tropical areas in the northern hemisphere have northeastern direction. Okay, just remember this, northeastern direction, where winds blow from northeast to southwest in the northern hemisphere in the tropical areas, specifically along this Indian subcontinent area. And much of the rainfall during this time period is caused because of the northeastern trade winds. So a little bit rainfall is experienced in the southern parts of Tamil Nadu, southern parts of Andhra also, but most of the Indian subcontinent do not receive rainfall during the winter season. So you have prevalence of northeastern trade winds during this time period. So this diagram also shows the location of ITCZ, which shifts southward during the southern summers and establishes itself somewhere around 5 to 10 degrees south of equator, and during the northern summers it shifts northward and establishes itself somewhere around 15 to 25 degree north in the northern hemisphere. And this shifting of ITCZ greatly impacts the convergence of trade winds in both the time periods, which defines and gives unique characteristics to the existing monsoonal winds in the South Asian region, specifically over the Indian subcontinent. So this shifting of ITCZ actually gives the special characteristics to the monsoon winds, because of which there is 180-degree reversal of monsoon winds during the summer and winter seasons. So as this ITCZ demarcates a convergence zone of trade winds blowing from both the hemispheres. Divergent winds are produced in anticyclonic zones. Consequently, the northeast trade winds blow from these regions and travel southward towards the equator to converge with the southeast trade winds blowing from subtropical high pressure belt regions of the southern hemisphere. So as we know that because of extreme cold conditions, you have very high pressure conditions which developed in the northern parts of Asia and Central Asian region. And due to existing high pressure conditions on ground, the northeast trade winds, they start blowing out from these high pressure areas originating from northeastern side and blowing towards the southwestern regions. Why this specific direction is there? Because of Coriolis force. The winds are deflected towards the right in the northern hemisphere. And because during this particular time period, the ITCZ has established itself somewhere south of equator. So these northeast trade winds, in order to merge with the southeast trade winds, they cross the equator, and in the process they become northwestern. And finally, they are able to merge with the southeastern trade winds somewhere in the southern hemisphere near the equator. So the whole Indian subcontinent actually experiences the northeast trade winds during the winter season, which are also called as northeast or winter monsoons in India, and they are responsible for some precipitation along the eastern coast of India around Tamil Nadu and Andhra Pradesh and Orissa also. Also during this time period, due to presence of subtropical westerly jet streams, which is also called as western disturbances, and because of the existence of subtropical westerly jet stream in the northwestern region of India, the Punjab and Haryana region and the northern Rajasthan region receives rainfall during this time period. So certain northwestern regions of Indian subcontinent receive the winter rainfall due to subtropical westerly jet stream, and certain areas around the Tamil Nadu and the southern eastern coast of India receive rainfall due to northeast trade winds. So one of the most significant thing which is important to note here is that the direction of existing trade winds is from northeast to southwest direction. This is the actual direction of the monsoon winds during the winter season. Now, what happens during the summer season? There is total reversal in the direction of winds. The conditions are reversed and there is 180-degree reversal of existing wind system due to apparent northward movement of the sun with the approaching summer solstice in the northern hemisphere. So with the summer season in the northern hemisphere, you have high temperature in the northern hemisphere, okay, and low pressure conditions, due to which all the pressure belts shift northward, and contrary to this, you have high pressure conditions in the southern hemisphere due to low temperature. So along with all the pressure belts, the ITCZ also shifts northward and establishes itself somewhere around 25 to 30-degree north in the northern hemisphere. So over the Indian subcontinent, it establishes itself along the North Indian Plain region. And the North Indian Plain region is heated immensely during this time period, creating very intense low pressure conditions, due to which the trade winds of the southern hemisphere are pulled northward to this particular intensive low pressure center, which is created over the northern plain region and northwestern region of India. As we know that we have Thar desert in that area. So now the southeast trade winds are pulled towards this low pressure center. So as they are pulled towards this low pressure center, they cross the equator. And as soon as they cross the equator, due to existing Coriolis force, they become southwest in direction, because they are deflected towards their right under the effect of Coriolis force as they cross the equator, and they continue their northward journey. Now, as the southwest trade winds continue their northward journey and approach the Asian landmass, which is very intensively heated and is the center of low pressure, and since these southwest trade winds travel long distances over a vast expanse of water in the Indian Ocean, Bay of Bengal region, Arabian Sea region. So by the time they reach the southwestern coast of Indian subcontinent, they are oversaturated with moisture and causes heavy rainfall along the western coast of Indian subcontinent. So heavy rainfall showers are experienced in India and neighboring countries due to the arrival of southwest trade winds in the region. The monsoon winds flow over India, Pakistan, Bangladesh, Myanmar, Sri Lanka, Arabian Sea, Bay of Bengal region, and Southeastern Asia, Northern Australia, and China also. However, it is most extensively developed over the Indian subcontinent, and India receives its 80% of rainfall during the 4 monsoon months from June to September. So you can see that in the winter time period, we had the monsoonal wind direction from northeast to southwest, and northeast trade winds, they prevail in the entire Indian subcontinent. However, during the summer season, this condition is reversed. Now you can see that you have the southwest trade winds moving towards the northeastern region, bringing immense precipitation on hitting the Indian landmass. So you can see that there is complete 180-degree reversal of wind direction during the summer and winter season. And outside India, in the East Asiatic countries such as China, Japan, the winter monsoon is stronger than the summer monsoon, because obviously it is coming from the northern part, so it will give more precipitation towards the coastal regions of China also. So it is apparent that monsoon are such seasonal winds which experience variable characteristics, specifically the changes in the direction of the movement of winds with the changes of season in a particular year. Therefore, they are considered to be the most prominent seasonal winds. Now, besides the monsoon winds, another type of winds, which are valley and mountain breeze or valley and mountain winds, are also considered as secondary wind circulation. However, in various books, it is given that they are tertiary wind systems and they are local wind systems. But valley and mountain breeze, which cover extensive area regionally, are part of secondary wind circulation. However, in certain areas, the valley and mountain breeze can be localized to a very small area, and in that condition, they can become the local winds also. But preferably, they are part of secondary wind circulation. Now, these are periodic in nature and they are experienced with different characteristics in different time periods of the day. So during the daytime, you have valley breeze. Now, what do you understand by valley breeze? So during the daytime in the mountainous regions, the mountain tops warm up quicker as compared to the valley regions, because of which the air above the mountain tops become lighter and it starts ascending, creating a low pressure region. To fill the resulting gap, the cooler air from the valley is attracted towards this low pressure regions on the mountain tops. So winds blow from high pressure towards the low pressure area. Therefore, the wind start moving from the high pressure area of the valley bottoms towards the low pressure area of the mountain tops, and therefore the daytime breeze or daytime winds which blow from valley regions toward the mountain tops are called as valley breeze or valley winds, and these winds blow specifically during the daytime. Contrary to this, during the night time, we have mountain breeze. So the process is reversed. As you can see, in the evening time period, the air on the mountain tops becomes cool faster as compared to the bottom valley regions, and the cool dense air creates high pressure over the mountain tops. Contrary to this, in the valley regions you have low pressure, because the valley regions are still comparatively warmer as compared to the mountain tops. So again, the wind starts moving from the high pressure areas towards the low pressure areas. The cool dense air from the mountain top starts sinking and slides down the slope. Okay, it starts sinking and it slides down the slope of mountain and fills up the valley region, because the cold wind is denser. So it slides past beneath the warm air of the valley floor, which causes the warm air in the valley regions to push upwards. Obviously, if the valley floor will be filled by the cool dense air, so as a result the comparatively warm air which is existing in the valley floors will be pushed upwards. This breeze, which blow from the mountain top regions and slides and sinks towards the valley bottoms, is called as mountain breeze. And this phenomena leads to temperature inversion conditions and create dense fog in the valley regions, which is visible in many areas during the early morning hours also. And this phenomena is more pronounced during the winter season. Of course, why? Because during the winter you have more dense, more cold winds which blows from the high mountain tops towards the valley bottoms, and it takes time for that cold dense air to dissipate once the sun rises during the morning time period also. So you have daytime valley breeze and you have nighttime mountain breeze, and they are both secondary wind circulation, periodic in nature, with reversed characteristics during the daytime and nighttime. Now coming to anabatic winds and katabatic winds. So anabatic winds are more or less synonymous to valley breeze or upslope winds. Okay, so when due to existing low pressure conditions over the mountain tops and high pressure conditions in the valley regions, the warm air, it ascends the slope of the mountain. It is called as anabatic winds or upslope winds. They are driven by heating of the mountain tops and higher slopes, creating low pressure zones over the mountain tops, which attract the winds from the valley bottom regions towards this low pressure mountain tops. And on reaching up, these winds cool down, forming cumulus clouds, leading to precipitation along these slopes. So as these winds, they ascend this slope, the temperature of this air parcel decreases. Okay. And as the temperature of this air parcel decreases after reaching a particular height, it condenses to form cumulus cloud, leading to precipitation along this slope. So these warm upslope winds are called as anabatic winds. Now, opposite to anabatic winds, we have katabatic winds during the night time. So katabatic winds are more or less similar to the mountain breeze or downslope winds. These winds primarily originate due to radiational cooling of air on top of mountain, plateau, hill, glacier areas. So because of cooling down of mountain tops comparatively faster to the valley regions, the mountain tops become areas of high pressure, and the valley regions remain comparatively areas of low pressure. So during the night time, cool dense air sinks, slides along the slope towards the low pressure area at the valley bottom regions and drained into the valley, which are called as katabatic winds. So because the cold wind is continuously drained into the valley floor, these types of areas are generally devoid of any kind of settlement or agriculture because of existence of very dense foggy conditions which are detrimental for agriculture and homes also. Therefore, in such areas, the homes are situated on hill slopes above the lowlands where the cold air accumulates. So in order to prevent the detrimental effects of fog, the homes are primarily situated along the higher areas in these slopes. So basically katabatic winds are downslope winds which blow from high mountain areas towards the valley floor regions. So this was one type of katabatic wind which was detrimental because of the accumulation of cold air along the valley bottoms. Another type of katabatic wind which is warm occurs on the leeward side of the mountain once the air releases moisture along the windward side due to precipitation. So if the moisture laden winds are forced to ascend a mountain barrier, during their ascent they are cooled, leading to formation of clouds causing precipitation along the windward side. But as soon as they reach the mountain tops or plateau tops, they start sinking along the leeward side and warms up due to compression. Okay, so as the air start descending towards the valley bottoms, what happened? Near the valley bottom, you have more atmospheric pressure, which leads to the compression of this air parcel which is descending the valley. And as a result, these particular air become warm when they reach the valley floor. So a large scale katabatic wind that descends too rapidly to warm up is called as fall wind also. As you can see in this diagram, the plateau cooled air falling from top of Maktesh Plateau, the air is warmed as it descends from the top of the plateau regions towards the valley floor, and the fog re-evaporates as it falls. And this dry air melts down the snow along the valley slope, and it is good for agriculture and orchards. So you have two types of katabatic wind. One is detrimental, one causes the accumulation of fog, accumulation of cold winds in the valley regions. Another type of warm katabatic wind blows in the leeward side of the mountain of the plateau, where when it descends it warms up due to compression, which is also called as adiabatic warming of the air parcel. And we will be studying the adiabatic warming, adiabatic cooling in the coming videos. But due to compression of air parcel as it descends, because we have more atmospheric pressure near the sea level, so definitely the valley bottoms will have more pressure as compared to the mountain tops. So you have nighttime katabatic winds. And these winds also showcase secondary wind circulation changing periodically. Besides this, you also have land and sea breeze. The land and sea absorbs and transfer heat differently, leading to periodic changes in air circulation during daytime and nighttime. So land and sea breeze are another kind of periodic winds which occur primarily due to the changes in the pressure and temperature conditions of a particular area during a particular time period of the day. So what happens during the daytime? We have sea breeze. Why sea breeze? Because during the daytime the land heats up faster as compared to the sea. So we are always taking comparative pressure conditions. In case of mountain and valley breeze also we have taken comparatively mountains becoming hot, then valleys, and valleys becoming hot compared to mountain areas. So it is always a comparative pressure which we take. So during the daytime, the land heats up faster as compared to the sea. So over the land, you have low pressure due to high temperature during the daytime. The land becomes more warmer Then sea. So sea surface temperature will be comparatively cooler, due to which you will have high pressure over sea. As a result, we already know that winds blow from high pressure towards the low pressure. So cool winds will blow from the high pressure sea surfaces towards the low pressure land areas, and therefore it is called as sea breeze. Low pressure over land primarily due to high temperature, and high pressure exists over sea due to relatively low temperature. Thus, pressure gradient from sea to land is created, and the winds blow from the sea towards the land as the sea breeze during the daytime and bring soothing effect to the warm coastal areas during the daytime. So in the coastal areas during the daytime, if you move close to the sea, you can actually feel the cool air coming from the sea during the daytime as compared to the warm winds which are blowing over the land area during the daytime. So you have daytime sea breeze. Now, contrary to this, during the night time, the land loses heat more rapidly compared to the sea. So you will have high pressure over land, and you will have comparatively low pressure over sea. The land becomes cool as compared to the sea, and high pressure over land exists, whereas low pressure over sea prevails. The pressure gradient now is reversed. Initially, during the daytime, it was from sea to land. Now, during the night time, the pressure gradient has reversed. It has become from land to sea. So, the air will also blow from the land areas towards the sea areas during the night time, which are also called as land breeze or land winds. So you can see complete reversal of wind cycle during the two time periods in a particular day. While during the daytime, the pressure gradient is from sea to land. During the night time, the pressure gradient is from land to sea. So daytime you have sea breeze and nighttime you have land breeze. But it is not fixed that the land and sea breeze will only be secondary type of wind circulation. Sometimes the land and sea breeze systems are very localized, located to very small area also. So land and sea breeze at times also become part of local circulation confined to very small local area also. So you may have variants of land and sea breeze, mountain and valley breeze, anabatic and katabatic winds as part of local wind systems also. But mostly they are recognized as regional winds or secondary wind circulation systems. Coming to the summary of the video, secondary winds are periodic winds. They are regional winds which occur in different locations throughout the world. They are highly influenced by the regional geographical conditions on one hand, and because of the limited regional extent, they influence greatly the weather and climatic conditions of a limited regional geographical area also. So one of the most commonly recognized seasonal winds are monsoon winds, which were initially considered as modified or unique type of land and sea breeze. However, today they are recognized most prominently as secondary winds, which are characterized by complete reversal or 180-degree reversal of wind direction from winter season to summer season, or from one season to another season in a particular year. Besides this, we have periodic winds also, just as valley and mountain breeze, anabatic and katabatic winds, land and sea breeze, which are another set of secondary wind circulations, and they are primarily observed due to changes in the pressure and temperature conditions of a specific distinctive region. Okay, so most of these winds are periodically experienced during daytime and nighttime in a particular day. So along with planetary wind systems at global level, the secondary wind circulation is also very significant and they have high influence on the regional weather conditions of a particular area, bringing that unique characteristics of weather and climatic conditions to a particular area. So they add distinctive characteristics to the weather conditions which exist in a particular area by adding periodicity, variability, seasonality to the winds which occur and which blow over a particular area. So this was all about secondary wind circulation or regional winds. I hope the video was informative. Thank you so much.